All right, so we're on page 7 here. This is, again, no calculator. And we have yet again another graph that we're looking at, although this time it's f prime. So let f be a function defined on the closed interval -3 to 4. F of 0 is 3. The graph of f prime is a line segment and a semicircle. Okay. On what intervals, if any, is f increasing? Justify your answer. So like I've said on previous pages, I tend to justify first. So f is increasing when f prime of x is greater than 0. And then I'll look for when that's happening. So here's the f prime graph, greater than 0 just on this little section. So I'm going to say on the interval -3 to -2. I'm not including those endpoints because, I am including -3 because -3 f prime is definitely positive, but at -2 f prime is equal to 0. So that would represent like a changeover point, a relative maximum on f, so not increasing at that point. All right, that's all we had to do for part A. For part B, find the x coordinate of each point of inflection of f. Justify your answer. So again, I'm going to start with the justification. So f is concave up when f double prime of x is greater than 0. What does that mean, though? Because we have an f prime graph, we don't have f double prime. So what does that mean? That equates to when f prime is increasing, right? Because if its derivative is positive, the function is increasing. So I'm looking for where f prime is increasing, and that's happening just on this section here. So between 0 and 2 on interval 0 to 2. All right, let's see. Find an equation for the tangent line at the point 0, 3. So we need a point, which we were given, 0, 3. We need a slope. Now the slope would be the value of f prime at this point, so at 0. So what is f prime at 0? Go to the f prime graph, find its value. That's equal to -2. Write the equation for the tangent line, so that's y minus 3 equals -2. You can write x minus 0, or you could just write x right there. You could also use slope-intercept form since the point that we were given was a y-intercept, so lots of options. Find f of -3 and f of 4. Show the work that leads to your answers. So when you're finding points and you're given derivative information, you should be setting up the fundamental theorem of calculus. So remember, the point that you're working with is f of 0. So if I'm finding f of -3, that's left of 0, right? So it's going to be f of -3 plus the change in position from -3 to 0 of f prime of x dx is equal to f of 0, right? Start at -3, add the change in position, land at this endpoint, which is 0. F of -3, we don't know. Let's find this area here. So from -3 to 0. So here's -3 up to 0. So, okay, this area is going to be 1/2 times 1 times 1. And then we're subtracting the other area. It's negative 1/2 times 2 times 2. And that's equal to f of 0, which we were given as 3. Now I just do the math here. So f of -3 plus 1/2 minus 2 is equal to 3. F of -3 is equal to, so I'm going to add 2 to get 5. I'm going to subtract 1/2 to get 4.5, 4.5, or 9/2, whatever. Decimals are fine. Fractions are fine. I wouldn't do a mixed number like 4 and 1/2 because that just can look confusing. But it's not wrong. And then what about f of 4? So f of 4 is to the right of f of 0. So this one's going to be start at f of 0, add the change in position from 0 to 4. of f prime of x dx. Make sure that you're using the right notation too. If you're not writing dx's here, then your work is not right and you're not getting credit for it. That would land you at f of 4. F of 0 is 3. What's the area from 0 to 4? So take a look at this area here. We're looking for this area. Now, what is that area? It's not just like the area of the semicircle, right? Take a look at this. What you really need to do is find the area of this big rectangle and subtract the area of that semicircle, and then you'll be left with that upper portion. So the area of the rectangle, and it's negative, right? So the area of the rectangle is negative 8, or let's just do this. The area of the rectangle is 8, 4 times 2. The area of the semicircle is pi 1/2 times pi r squared. R is 2, right? You're going from 2 to 4. So the net area here is equal to 8 minus 2 pi. But again, remember that I just made these positive areas. This is going to be negative. So subtract. All right, color here. Subtract 8, minus 2 pi. If that's kind of confusing, I think it is a little confusing with the subtraction there. Just think, if this net area was 10, if this came out to 10, then you would say, okay, but it's below the x-axis, so minus 10. So I'm doing the same thing, minus the net area I just got. And I can clean this up a little bit. 3 minus 8 is negative 5. This becomes plus 2 pi, or you could say 2 pi minus 5 is f of 4. That's that. All right, that finishes this page.